Lesson 2.11, Arrangements with Repetition. Our objective for this lesson is to be able to determine the total number of possibilities when a selection is repeatedly made from the same group of choices. All right, in this lesson, we're going to talk about the first of three different types of counting problems. Counting problems are where we're trying to figure out how many different possibilities there are. So today we're talking about arrangements with repetition, which is a type of counting problem in which we repeatedly select from the same group of choices and repetition is allowed. So this would be, for example, trying to figure out how many different phone numbers or license plates are possible, or how many different PINs or passwords we could create. It's usually where there's a certain number of digits and we have a certain number of characters that we can choose from to fill those digits, and we can repeat the characters as often as we want. So that's arrangements with repetition. And the formula for arrangements with repetition is pretty straightforward. This is essentially just the multiplication rule that we learned earlier. Remember, we talked about how many different outfits could we make if we had 5 different shirts and 3 different pairs of pants and 4 different pairs of shoes. And we said we just multiply them together, 5 times 3 times 4. Well, it's the same principle here. If, for example, we're trying to figure out how many different 6-digit PINs we could create if we're just using numbers, well, there's 10 different choices for each of the numbers 0 through 9. So we have 10 different choices for the first number, for the first digit, 10 different choices for the second digit, etc., through the 6 digits. So it'd be 10 times 10 times 10 times 10 times 10 times 10, 6 times. So 10 to the 6th power. So if we make R selections from a group of n choices, a total of n to the R different arrangements are possible. So in the case of our 6-digit PIN, it would be 10 to the 6th, which is 1 million different PINs are possible for if we have 6 digits, and it's possible to repeat the numbers. All right, our first example asks us to figure out how many different telephone numbers are possible in the state of Arizona. And we're told that there's 5 different area codes, and there's a 7-digit number. There's an area code and then a 7-digit phone number. And these digits will change. The area codes are just going to be those 5. So all we really need to do is figure out how many different phone numbers are possible for each area code, and then we'll multiply that by 5. So for each area code, we've got a 7-digit number, and for each of these digits, we can use the numbers from 0 to 9. So there's 10 different numbers available for each of these digits. So we could have 10 here, 10 here, 10 here, and we can repeat numbers as much as we want. And so we're just going to multiply 10 times 10 times 10 times 10 times 10 times 10 times 10. So that's 10 to the 7th power. So 10 to the 7th power is going to be equal to 10 million. 10 million different phone numbers are possible for each of the area codes. And so to figure out how many total number of phone numbers are available in Arizona, we just need to multiply this times 5. So we have a total of 50 different phone numbers that are available in the state of Arizona. The second example asks us how many license plates are available in Arizona following this format: letter, 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 number, 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 number. So in Arizona, our license plates generally follow the pattern of 3 letters followed by 4 numbers. And we want to know how many of those types of license plates are available. So this is going to be the same as before, only now we've got letters, and there are 26 letters in the alphabet. So there's 26 different possibilities to choose from for each of these first 3 digits. So we've got 26 times 26 times 26 times, now we've got 10 numbers to choose from for the last 4. So 10 times 10 times 10 times 10. And another way to write this is 26 to the 3rd times 10 to the 4th. And 26 to the 3rd is 17,576, and 10 to the fourth is a 1 and 4 zeros, so that's 10,000. And 17,576 times 10,000 is going to be 175,760,000. So that's how many license plates are possible following this format in the state of Arizona. Our last example asks us how many 8-character passwords are possible if we can use lowercase letters, uppercase letters, numerals, and these 5 special characters. So the first thing we need to do is figure out how many different choices we have for each of our digits, or for each of our characters in our password. And so for lowercase letters, there's 26 of those. Uppercase letters, there's another 26. Numerals, that's 10. And there's 5 of these special characters. So all together, we have 26 plus 26 is 52, plus 10 is 62, plus 5 is 67. 67 different characters that we can use, or different choices that we have for each of the characters in our password. So, so we've got 67 choices, and we're making that choice 8 times. So that's going to be 67 to the 8th power. And I am going to need a calculator for this. This number is 406,677,556,641. That's how many choices are available for an 8-character password if we can use lowercase, uppercase, lowercase letters, uppercase letters, numerals, and those 5 special characters.